The morning air at Kummersdorf proving grounds carried the metallic scent of spent cordite and diesel exhaust. It was December 7th, 1944, and a peculiar machine sat on the firing range south of Berlin, an American tank, captured intact during the autumn fighting in Lorraine. The M4A3E8 Sherman, still bearing the scars of combat, waited in the cold as German engineers prepared their instruments. They had tested captured enemy equipment before, Russian T-34 seconds, British Churchills. Always the same result, confirmation of German technical superiority. This morning would be different. The men at Kummersdorf were about to discover something that would shake the comfortable assumptions of Wehrmacht armored doctrine, not through defeat in battle, but through the cold mathematics of ballistic science. Understanding the shock that would ripple through the German testing facility requires understanding what these engineers believed they already knew. By late 1944, a narrative had solidified within German military circles, built on years of combat experience and reinforced by propaganda. German tanks were superior. This wasn't merely boastful rhetoric, it was a conclusion drawn from battlefields across Europe. The Panzer IV, backbone of the Wehrmacht's armoured divisions, had evolved throughout the war into a formidable fighting vehicle. Its long-barreled 75mm KBUK 40 litres, 48 gun, had proven itself against Soviet armour on the Eastern Front and against American tanks in France. German tankers approached each engagement with a psychological advantage rooted in technical confidence. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The Sherman tank, by contrast, had earned a grim reputation. To German soldiers, it was a Tommy cooker, a sardonic reference to its tendency to burn when penetrated. American crews called them Ronsons, after the cigarette lighter advertised to light first time, every time. These nicknames weren't mere dark humour, they reflected a harsh battlefield reality. Early Sherman variants mounting the standard 75mm gun struggled against German armour. At ranges beyond 1,000 yards, their armour-piercing shells frequently bounced off the frontal plates of Panthers and Tigers. Even against the more common Panzer IV, American tankers found themselves forced to close distance, seek flanking positions, or rely on numerical superiority to achieve kills. The technical specifications told the story. The Sherman's 75mm M3 gun fired an M61 armour-piercing capped ballistic cap round with approximately 92mm of penetration at 500 yards against armour angled at 30 degrees. The Panzer IV's frontal armour measured 80mm thick, vulnerable at close range when struck properly, but the geometry of combat rarely allowed such ideal conditions. German tanks engaged at distance, using superior optics and crew training to strike first. The psychological calculus was simple. German crews could kill Shermans before the Americans could effectively return fire. Combat reports from Normandy reinforced this confidence. In the hedgerow country of northern France during the summer of 1944, German armour commanders regularly reported knocking out Shermans at ranges where American return fire proved ineffective. A Panzer IV crew operating from a prepared position could engage approaching Shermans at 1,500 metres or more, using their excellent Zeiss optics to identify targets and estimate range with precision. By the time American tanks closed to effective firing distance, several might already be burning. The Wehrmacht's armoured doctrine emphasised this advantage. Use superior range and training to engage the enemy from positions of safety. Yet the Americans were adapting, though this evolution remained invisible to most German observers. In early 1944, recognizing the Sherman's limitations in tank versus tank combat, the United States Army began fielding a modified variant, the M4A3E8, nicknamed the Easy 8 by American crews, incorporated several significant improvements. Wider tracks, reduced ground pressure. The new horizontal volute spring suspension system improved cross-country mobility and provided a more stable firing platform. But the most critical change was the gun, a new 76mm M1A1 cannon that represented a substantial leap in anti-armor capability. On paper, the specifications were impressive. The 76mm gun fired the M62 armor-piercing capped ballistic cap round with a muzzle velocity of 2,600 feet per second, compared to the 75mm 2,030 feet per second. This velocity increase translated directly into penetration performance, approximately 157mm at 500 yards, nearly 70% more than the older gun. The M1A1 could, theoretically, engage German armor at ranges where the older Sherman was helpless. It changed the calculus of tank combat, or should have. But a strange thing happened when the first 76mm Shermans reached American armored divisions in France during the summer of 1944. Many unit commanders rejected them. The reason revealed much about how different armies approached armored warfare. The 75mm Sherman carried a superior high-explosive round, more effective for the tank's primary mission, supporting infantry. American doctrine held that tanks fought infantry, anti-tank guns, and fortifications. Tank destroyers lighter, more mobile vehicles like the M10 and M18 were supposed to deal with enemy armor. The Sherman was designed as an infantry support weapon that could defend itself against other tanks, if necessary, not as a dedicated tank killer. This doctrinal difference had profound implications. Many American tank commanders, given the choice between the 75mm Sherman with its better high-explosive shell and the 76mm variant with superior armor penetration, chose the former. Reports from frontline units were mixed. Some crews who received the new gun appreciated the additional anti-tank capability, especially after encountering Panthers. Others found the 76mm high-explosive round less satisfactory for infantry support work, making it a poor trade for the Sherman's intended role. The 76mm Sherman was better at killing tanks. American doctrine didn't prioritize killing tanks. German doctrine did. This asymmetry in tactical philosophy meant that even as an improved American tank arrived in theater, it entered a battlefield where its primary advantage wasn't fully exploited. German intelligence officers, reading captured documents and interrogating prisoners about the new American gun, noted its existence but remained confident. The Wehrmacht had the King Tiger, mounting the fearsome 88mm Quay 43 gun. They had the Panther, whose sloped armor and 75mm L-70 gun made it arguably the best medium tank in the world. Even the standard Panzer IV had proven itself repeatedly. How much could this American upgrade truly matter? In October of 1944, during the Lorraine campaign, Wehrmacht forces captured an M4A3E8 that had been disabled by a mechanical failure or lucky shot. The records are unclear. What mattered was that the tank was substantially intact and repairable. Someone in the German command structure made a decision: transport this captured vehicle to Kummersdorf for comprehensive testing. Standard procedure for captured enemy equipment. Evaluate its capabilities systematically. Identify weaknesses. Most importantly, quantify exactly how inferior this American machine was compared to German designs. The captured Sherman arrived at Kummersdorf in early November 1944. The facility had served as the Wehrmacht's primary weapons testing center since 1875, a sprawling complex of firing ranges, armored bunkers, and technical workshops south of Berlin. This was where Germany's most advanced weapons were evaluated, where the Tiger tank had proven its worth in 1942, where the Panther's teething problems had been identified and addressed, where every new gun, every new armor plate, every innovation was subjected to rigorous scientific analysis. German mechanics set to work refurbishing the Sherman. This wasn't about testing a damaged wreck. They needed the vehicle fully functional to generate accurate data. They replaced damaged components, ensured the engine ran properly, verified that the turret traverse and gun elevation mechanisms functioned correctly. By late November, the M4A3E8 was ready for systematic evaluation. The testing protocol followed established Wehrmacht procedures. Engineers would assess automotive performance, engine, power, transmission reliability, suspension characteristics, cross-country mobility. They would measure armor protection, plate thickness, angles, material quality, weld integrity. They would evaluate crew ergonomics, sightlines, control placement, escape hatches, ammunition storage, and finally, most critically, they would test the gun, range, accuracy, penetration, rate of fire. The initial tests confirmed German expectations. The Sherman's armor was adequate but unexceptional. Frontal armor on the M4A3E8 measured 64 mm thick on the upper glacis plate, set at an angle of 47 degrees from vertical. This slope increased the effective thickness to approximately 93 mm against direct fire. The Panzer IV had 80 mm of vertical frontal armor, similar levels of protection, achieved through different design philosophies. The Sherman relied on slope for effectiveness. The Panzer IV used thickness. Neither approach was clearly superior. They were simply different solutions to the same problem. The Sherman's power plant, a Ford GAA V8 gasoline engine producing 500 horsepower, was powerful and notably reliable, but it ran on gasoline, not diesel. German tanks had increasingly switched to diesel fuel where possible, particularly newer designs. Gasoline was volatile, a significant fire hazard when a tank was penetrated. Another confirmation of German assumptions. American design accepted greater fire risk in exchange for the simplicity and power of gasoline engines. The new suspension system impressed the German evaluators. The horizontal volute spring suspension that gave the E8 variant its nickname provided excellent mobility over rough terrain and a stable platform for gunnery on the move. It was demonstrably superior to the Panzer IVs leaf spring suspension, which had remained essentially unchanged since the tank's original design in the late 1930s. But suspension improvements, while tactically useful, didn't fundamentally alter the combat equation. A tank with excellent suspension could still be destroyed by a tank with a better gun. Then the engineers reached the gunnery tests. This was the critical evaluation, the measurement that mattered most. Standard procedure: fire the tank's main gun at armored target plates positioned at various ranges. Measure penetration depth. Record accuracy. Compare results against known performance data for German weapons. The engineers positioned steel plates equivalent to the Panzer IV's frontal armor at marked distances on the range. They began at 500 meters. The 76 mm M4A3E8 gun punched through the test plate cleanly. Expected result: the Panzer IV's gun could achieve similar penetration at this range. They moved 1,000 meters. Clean penetration again. still within the performance envelope of German guns, though the margin was closer. The American gun was performing well, but not surprisingly so. At 1,500 meters, just over 1,640 yards, the German observers prepared for the American gun to show its limitations. 1,500 meters was a long shot for medium tank armament. At this range, the Panzer IV's 75mm KK 40 liters, 48 gun firing the Panzer Granit 39 armor-piercing round could penetrate approximately 82mm of vertical armor at 30 degrees marginal against a Sherman's frontal armor, possibly inadequate against the sloped glacis plate. The 76mm gun fired. The armor-piercing round struck the test plate. The German engineers examined the result and checked their instruments. At 1,500 meters, the American gun had achieved clean penetration against armor equivalent to the Panzer IV's frontal protection. They ran the test again with fresh ammunition. Same result. A third time. Consistent penetration. One of the engineers pulled out the performance data sheets for the Panzer IV's main gun. He compared the ballistic curves. At 1,500 meters, using standard ammunition, the American 76mm gun was penetrating approximately 109mm of vertical armor. The German 75mm KGO 40 liters, 48, at the same range, was penetrating 82mm. The numbers were incontrovertible. The American gun was outranging the Panzer IV's main armament, significantly. At combat ranges beyond 1,000 meters, the Sherman's penetration advantage widened progressively. By 2,000 meters, the disparity became even more pronounced. The weapon that German tankers had dismissed as inferior, the gun mounted on a tank they'd been killing with relative ease, was, by purely ballistic standards, superior to their own. There must have been a moment of cognitive dissonance in the observation bunker at Kummersdorf. These were trained engineers, men who understood ballistics and armor penetration mechanics. The data was clear, yet it contradicted everything the frontline reports had said. German tankers had been engaging Shermans at ranges of 1,500 meters and beyond, winning these engagements consistently. American tanks were burning on battlefields across France. How could this be reconciled with test data showing the American gun was more effective at exactly these ranges? The answer lay not in the hardware, but in the human element in doctrine, training, and tactical philosophy. German tank crews were trained to engage at maximum effective range. Their entire tactical doctrine emphasized the first shot advantage. Use superior optics to spot the enemy early. Use superior training to estimate range accurately. Use superior crew discipline to achieve a first-round hit before the enemy could effectively return fire. German tank. Commanders typically stood in their turrets during combat, using excellent Zeiss optics to scan for targets. They practiced range estimation constantly, drilled on it until it became instinctive. The Wehrmacht's armoured doctrine had been refined through years of combat, from Poland through France through Russia, each campaign adding lessons learned. American crews fought differently. Their doctrine emphasized combined arms cooperation, with tanks supporting infantry rather than seeking tank versus tank duels. Most American tank commanders had trained for direct fire support missions, engaging bunkers, anti-tank guns, infantry positions. These were typically close-range engagements, fought at distances of 500 to 1,000 meters. Long-range gunnery against moving armored targets simply wasn't emphasized in American training. The doctrine said tank destroyers would handle enemy armor, so Sherman crews practiced the missions they were expected to perform. Moreover, Most American tank crews in Europe during late 1944 were inexperienced. The typical American tanker had perhaps 6 months of stateside training before shipping overseas. He might have a few weeks of combat experience, perhaps a handful of engagements. Compare this to veteran German crews who'd been fighting since 1939 or 1940, men who'd survived Poland, France, and years on the Russian front. The human element, experience, training, tactical sophistication mattered more than the hardware specifications. The German test report documented everything meticulously, ballistic tables showing penetration values at various ranges, comparative charts plotting the 76mm M1A1 against the 75mm KK 40 litres, 48, technical drawings of the gun mechanism, detailed notes on ammunition types, propellant characteristics, barrel wear rates. The engineers at Kummersdorf were thorough. This was their profession, their contribution to the war effort. The report's conclusion was unavoidable. The American 76mm tank gun demonstrated superior ballistic performance compared to the Panzer IV's main armament at all combat ranges beyond 1,000 meters. In technical terms, the Sherman M4A3E8 was adequately equipped, perhaps more than adequately, for encounters with Panzer IV tanks. This finding, the report noted with characteristic German understatement, required tactical consideration. Tactical consideration was military technical writing for "we have a problem." But by December of 1944, the Wehrmacht had nothing but problems. One more revelation about enemy equipment capabilities barely registered. The report was typed, stamped with appropriate classification markings, and distributed to relevant headquarters. It arrived on desks in Berlin, just as staff officers were grappling with far more immediate crises. The strategic situation facing Germany in December of 1944 was deteriorating rapidly. In the east, Soviet forces were preparing their massive winter offensive that would carry them from the Vistula River to the Oder, bringing the Red Army within striking distance of Berlin itself. In the west, American and British forces had recovered from the setback at Arnhem and were pushing toward the Rhine. In Italy, Allied armies were grinding through the Gothic line. In the air, British and American bombers were systematically destroying German industrial capacity and transportation networks. The war was being lost on every front simultaneously. Germany's tank production, despite Herculean efforts, couldn't keep pace with losses. In 1944, German factories produced approximately 6,000 Panzer IVs, 3,800 Panthers, and 600 Tigers and King Tigers combined. These numbers represented an impressive industrial achievement for a nation under constant aerial bombardment, but they weren't sufficient. The Wehrmacht was losing more tanks than it produced, not primarily to enemy tanks, but to mechanical breakdowns, fuel shortages, Allied air attacks, and the grinding attrition of sustained combat across multiple fronts. The German High Command read the Kummersdorf report. They noted the 76mm gun's superior ballistic performance. They filed the information appropriately, and then they did nothing, because there was nothing to be done. What response was possible? Upgrade the Panzer IV again? The design was exhausted, pushed to its limits. The chassis was already overweight and overstressed. The 75mm KGK 40 litres, 48, was the largest gun that could be mounted without a complete redesign of the turret and suspension. Germany had neither the time nor the industrial resources for such a project. Build more Panthers? German industry was trying. Panther production had increased throughout 1944, but the Panther required specialized machining, rare, alloying materials, and skilled labor. All of these were in desperately short supply. Moreover, the Panther was mechanically unreliable. Its transmission, gearbox, and final drives failed with depressing regularity. German maintenance units performed miracles keeping Panthers operational, but even their skill couldn't overcome fundamental design problems that would have required years of development to resolve. A tank that broke down before reaching the battlefield, regardless of how formidable its gun and armor, was tactically worthless. The bitter truth was this: Germany had known since 1943 that they were losing the war of industrial production. The turning point had been Stalingrad, not simply as a military defeat but as a revelation of scale. The Soviet Union was producing tanks at rates Germany couldn't match. The United States was producing everything: tanks, trucks, aircraft, ships, ammunition in quantities that defied comprehension. By 1944, American factories were building over 1,000 Sherman tanks per month. Good enough tanks, in overwhelming numbers, supported by limitless fuel, ammunition, and spare parts. Now, German engineers had discovered that these good-enough tanks weren't even inferior anymore. The 76mm Sherman represented a mature, refined design. Not revolutionary, the Americans hadn't invented some wonder weapon, but evolutionary, an incremental improvement that solved the problems identified in earlier models. And the Americans were producing them by the thousands. But here's the deepest irony embedded in the Kummersdorf test data. The American Army itself still didn't prioritize the 76mm Sherman. Even after the Ardennes offensive, the Battle of the Bulge, where German armor achieved tactical surprise and American forces faced Panthers and King Tigers in desperate fighting, the United States Army's official position remained that the 75mm Sherman was adequate for most missions. This wasn't bureaucratic stubbornness or institutional inertia. It was based on careful analysis of combat data. Detailed statistical analysis of American tank losses revealed something that challenged assumptions about tank combat. The vast majority of Sherman tanks destroyed in combat were killed by anti-tank guns, Panzerfaust rockets, and mines, not by enemy tanks. Tank versus tank engagements, despite their prominence in tactical doctrine and military theory, were relatively rare occurrences in actual combat. When such engagements occurred, American forces typically employed combined arms tactics: artillery support, airstrikes, infantry cooperation, and numerical superiority to defeat German armor. The 76mm gun's superior anti-tank capability wasn't irrelevant. Crews who had it appreciated the extra penetrating power, but it wasn't strategically decisive either. In the actual conditions of late-war combat in Europe, a Sherman tank's most important qualities were mechanical reliability, ease of repair and maintenance, crew survivability through intelligent internal layout, and most critically, availability. A tank that reached the battlefield, functioned properly, and could be quickly repaired when damaged was more valuable than a theoretically superior tank that broke down or couldn't be supported logistically. The United States produced over 49,000 Sherman tanks during World War II. Germany produced approximately 25,000 tanks of all types combined: Panzer IIIs, Panzer IVs, Panthers, Tigers, everything. When an American Sherman was destroyed, another arrived within days, sometimes hours. When a German Panther was lost, especially by late 1944, it might never be replaced. The arithmetic was brutal and inescapable. American tankers understood this reality instinctively, even if they didn't frame it in statistical terms. They joked grimly about needing 5 Shermans to kill a Tiger. This wasn't official doctrine, it was gallows humor. the kind of dark joke soldiers tell to process the absurdity and horror of their circumstances. But it reflected a deeper truth. The Americans would win through logistics, not through superior individual combat performance. They won by ensuring that the 6th Sherman arrived when the first 5 were burning. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The German engineers at Kummersdorf had discovered a technical truth. The American 76mm gun was excellent, probably superior to the standard German tank armament in its class. But that technical truth was strategically irrelevant by December of 1944. German tank commanders were running out of fuel. The elaborate network of supply depots that had supported the Wehrmacht's armoured divisions was collapsing under Allied bombing. Young crews, some barely old enough to shave, were being rushed through abbreviated training programs and sent to frontline units to replace casualties. The veterans who'd fought in France in 1940 and Russia in 1941 and 1942 were mostly dead or crippled. The tactical situation was even more dire. Allied air superiority over Western Europe was total. Daylight movement by German armoured units invited immediate attack by fighter bombers. American P-47 Thunderbolts and British Typhoons prowled the skies, hunting for German tanks and vehicles. Even the formidable King Tiger, impervious to most Allied tank guns, could be destroyed from above. German tankers learned to move only at night or in bad weather, concealing their vehicles in forests and villages during daylight hours. The operational mobility that had characterized blitzkrieg warfare was gone, replaced by desperate attempts to simply survive until nightfall. Whether the enemy's gun could penetrate your armor at 1,500 meters became a purely academic question when you couldn't reach the battlefield in the first place, when your supply lines were obliterated, when you had no air cover and the sky was full of enemy aircraft, when your fuel allocation was measured in liters, barely enough for short tactical movements. The Wehrmacht's armoured forces in the West were dying from 1,000 cuts, and the quality of enemy tank guns was far down the list of problems. The Kummersdorf report became just another document in Germany's rapidly collapsing bureaucracy. It was filed in the appropriate cabinets. Copies were sent to WA-Proof, the weapons testing office. Relevant sections were probably extracted and forwarded to tactical doctrine committees. And then it was forgotten, overtaken by more immediate crises. Because knowing your enemy's weapon is technically superior doesn't help when you've already lost the war of production, logistics, and attrition. The M4A3E8 Sherman tank, tested at Kummersdorf Proving Grounds, survived the war. When Berlin fell in May of 1945, Soviet forces captured the facility intact. Among the vast quantities of German military material they seized were mountains of test data, technical documents, and captured equipment. The Soviets found the Sherman, still in working condition, along with the detailed German test reports documenting its capabilities. Soviet engineers were intensely interested in this data. The Red Army's own experience with tank warfare had followed a similar trajectory to the Americans. Initial designs proved inadequate against German armor, requiring urgent upgrades. The T-34 medium tank, justly famous as one of the war's best armored vehicles, had initially mounted a 76mm gun that struggled against later German tanks. In 1944, the Soviets introduced the T-34-85, armed with an 85mm gun specifically designed to counter Panthers and Tigers. Soviet tank doctrine had evolved through brutal combat experience on the Eastern Front, where armoured engagements were larger and bloodier than anything seen in the West. The Kummersdorf documents revealed that the Americans had solved similar problems through different methods, not with a completely new design, but with incremental improvements to existing vehicles. The 76mm Sherman wasn't revolutionary, it was evolutionary. Good enough, produced in massive quantities, deployed in time to matter. This lesson influenced post-war Soviet tank design philosophy. Western military observers during the Cold War often noted that Soviet tanks seemed crude compared to American or British designs. Simpler fire control systems, less sophisticated optics, Spartan crew accommodations, basic mechanical systems. But this was intentional, rooted in lessons learned from examining documents like the Kummersdorf-Sherman test report. The Soviets concluded that technical sophistication was less important than reliability, ease of production, and availability in numbers. A tank that could be manufactured quickly, maintained by conscript mechanics, and produced by the thousands, was more valuable than a technically superior vehicle available only in limited numbers. Soviet Cold War tanks, the T-54, T-55, T-62 series, embodied this philosophy. They were good enough, produced in staggering quantities, and designed for the brutal arithmetic of industrial warfare. The Americans, interestingly, drew opposite conclusions from their World War II experience. After 1945, traumatized by how close-run some tank engagements had been, the United States Army determined that American soldiers would never again fight with equipment that was merely adequate. This institutional decision drove post-war American tank development. The M26 Pershing heavy tank, which had arrived too late to see significant combat in World War II, became the basis for the M46 Patton series. Then came the M47, M48, M60, and eventually the M1 Abrams, each generation more sophisticated, more powerful, and more expensive than the last. The Sherman became a symbol of wartime compromise in American military memory. Evidence that the United States had sent its soldiers into battle with adequate, rather than excellent equipment. The fact that the Sherman's actual qualities, reliability, maintainability, ease of production, logistical supportability, were precisely why America won became obscured by post-war narratives. The story became, "We won despite the Sherman, not because of it." This narrative served institutional purposes, justifying post-war investments in more capable armor, but it fundamentally misread the lessons of 1944 and 1945. What the Kummersdorf tests actually proved was that the Sherman wasn't inferior. By late 1944, with the 76mm gun installed, it was a genuinely good tank. The M1A1 gun was excellent. The horizontal volute spring suspension was arguably the best fitted to any medium tank in the war. The Ford GAA engine was both powerful and reliable. The crew layout prioritized survivability. Ammunition was stored low and protected by water jackets after early models were modified following combat experience. Vision blocks were adequate. Escape hatches opened outward for quick evacuation if the tank was hit. What the Sherman lacked was mystique. German tankers spoke about the Panther the way fighter pilots discussed the P-51 Mustang, with reverence, pride, even affection. It was a beautiful machine, a triumph of engineering, sleek and deadly. The fact that it broke down constantly, consumed fuel at an alarming rate, and was nightmarishly difficult to maintain in field conditions became conveniently forgotten in post-war mythology. The Tiger and King Tiger acquired similar legendary status, remembered for their thick armor and powerful guns. While their mechanical unreliability and tactical inflexibility were downplayed, the Sherman was the opposite: utilitarian, pragmatic, boring. It didn't break down often, which meant crews didn't develop the love-hate relationship that comes from maintaining temperamental machinery. It didn't have an intimidating gun or dramatically sloped armor or a fearsome battlefield reputation. It was simply there, day after day, doing the job it was designed for. This reliability made it forgettable. Tanks that work consistently don't generate stories. Tanks that fail dramatically do. The men who actually fought in Shermans, the ones who survived, generally held positive opinions about their tanks. They appreciated practical considerations that don't feature in technical specifications or historical debates. The hatches opened outward, allowing quick escape if the tank was penetrated, a significant improvement over early models. The ammunition storage, after modifications, was protected by water jackets that significantly reduced the fire risk that had earned the Sherman its grim nicknames. Spare parts were always available. If your tank was damaged but repairable, it would be fixed quickly because every Sherman used standardized components. Most importantly, if your tank was destroyed, another Sherman would arrive tomorrow, or the day after, certainly within the week. This logistical reliability provided psychological comfort that's difficult to quantify but vitally important. Sherman crews knew their tank wasn't invincible. They knew German tanks could kill them. But they also knew the American industrial machine would replace losses, that they wouldn't be left stranded without equipment, that the war would be won through sheer material superiority. This knowledge mattered more than gun penetration values at 1,500 meters. But reliable and available isn't as emotionally satisfying as powerful and feared. Post-war histories emphasized dramatic tank duels, elite German units, and technical specifications. The Sherman became the underdog tank, the adequate machine that won through numbers rather than quality. This narrative served certain institutional purposes but missed the fundamental point. The Sherman was designed to win an industrial war, and it succeeded completely at that mission. The German testers at Kummersdorf discovered something the history books often forget. The Sherman was a good tank, not despite its design philosophy, but because of it. The 76mm variant was technically superior to the Panzer IV, the gun that German commanders had trusted throughout the war. The reason German tankers consistently won individual engagements wasn't superior equipment. It was superior tactics, training, and experience. Veteran crews in inferior tanks were defeating inexperienced crews in superior ones. That's not about hardware. That's about the human element of war. There's a document preserved in the United States, National Archives, a translated copy of the Kummersdorf test report on the M4A3E8. It's stamped with various classification markings, now faded and declassified. Most of the document is dry technical language, ballistic coefficients, penetration tables, mechanical specifications. But buried in the gunnery section is a single paragraph where the German engineer notes, almost as an aside, that the American 76mm tank gun demonstrates ballistic performance exceeding that of the German 75mm Kai 40 at all combat ranges. Penetration values suggest American medium tanks are now adequately equipped for encounters with Panzer IV. This development, the paragraph concludes, requires tactical consideration. Tactical consideration, clinical language for a significant problem. But by December of 1944, Germany faced so many interlocking crises that one more adverse report barely registered. The Wehrmacht's tank commanders continued fighting with the tactics and training that had served them since 1940, because those were the only advantages remaining. German crews were still better trained than most American crews. They still had excellent optics. They still understood how to use terrain and positioning. These human factors mattered more than gun specifications, and the Americans kept producing Shermans, 75mm, 76mm. It barely mattered strategically. What mattered was the next Liberty ship arriving with 300 tanks, the next freight train carrying fuel and ammunition, the next replacement crew, green but adequately trained, ready to take over a repaired tank and continue the advance. The war's outcome wasn't decided at Kummersdorf proving grounds. It was decided in the factories of Detroit, the shipyards building Liberty ships, the training camps producing thousands of competent tank crews. Technical superiority was a bonus, not a requirement. The German engineers who tested the captured Sherman discovered an important truth too late for it to matter. Their report disappeared into a collapsing bureaucracy, one more piece of evidence that the war was already lost. But the lesson remains, preserved in archives, embedded in survival statistics, remembered by veterans who trusted their Shermans to bring them home. Superior technology doesn't win wars. People win wars. Logistics wins wars. Industrial capacity wins wars. Training wins wars. The ability to put good enough equipment in the hands of enough people who know how to use it wins wars. The 76mm Sherman was an excellent tank. The Germans proved it through rigorous scientific testing. Then they lost anyway, because excellence in individual weapons systems doesn't overcome strategic exhaustion. The Sherman survived not because it was the best tank it wasn't, but because it was good enough, available in quantity, and supported by a logistical system that kept it running. That's not a failure of design. That's exactly what it was designed to do. The Americans understood something the Germans never quite grasped. In industrial warfare, good enough is better than perfect. Reliable is better than sophisticated. Available is better than superior. Sometimes the most important truth isn't what works best in controlled testing. It's what matters when everything is chaos, when supply lines are stretched, when crews are exhausted, when the complexity of actual combat renders theoretical advantages meaningless. The Germans at Kummersdorf discovered that the American tank gun was superior. In the larger context of 1944, it didn't matter. The war was already decided by forces far beyond the ballistic performance of tank cannons. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.